For those of you on the Zoom, can you hear me just fine? Like just send a message in the chat. Yep. Okay, cool. Sweet. All right, let's go ahead and get started. So I'm going to hide this little thing. Hide like that. Aha. All right, cool. So some basic announcements. Homework 3 was due just now. I just got done saying that. If you joined late, like a lot of you also joined the class late, like last week, right before the deadline, that's totally fine. Just try to get it in as soon as possible so that you're not backlogged. Office hours are doing great. We seem to have a lot of people, like 12 people right before this one, or before lecture. So hopefully it gets a little bit more evenly spread out throughout the week. But like consistently, we're seeing 4 or 5 students. Please come if you need help. I've had several of you email me asking, what do I do? I'm falling behind. I don't understand the material in lecture. And we have an office hour every day for that very reason. We want to make sure that you understand coding and how to use it. So please come. And also we have a Discord. I realized I didn't have notifications on. That's my bad, for me at least. But Megan's also on there, and so are all the facilitators. And if you ask a question, please don't feel like ashamed if you don't understand or something. Please don't, because I guarantee you there's more than one person that feels the same way you do about something. So if you ask a question, it will also help your fellow students and peers. Grades for the first few homework assignments should be coming soon. We're starting to grade the first 3 homework assignments. We've been a little slow on that just because there's been people joining the class late, and we don't want to just post the solutions when they're still trying to work on the homeworks. So furthermore, encouragement to try and get your homeworks in before like the end of this week, hopefully, so that we can give everybody the solutions that they want to look at to compare to their like homeworks and learn from. Cool. The attendance form is right here. You can also scan this QR code. So please do that if you haven't. Again, these slides will be posted. Apologies for not posting them right after Thursday's lecture last week. Thank you to whichever facilitator did that for me. Like this week, we will be a lot more cautious about that and make sure that we post them right after. But yeah, keep up the good work, everybody. It's been nice to see like the effort now. I think over Zoom, like nobody really tried and nobody really cared. So I didn't know how hard these homeworks were. Definitely in person is a little different. So thank you for like coming to office hours and showing us how much you understand, coming to lecture. I just really wanted to say I really appreciate that. So thank you. I guess before we move on, is there any questions that I can answer? Okay, cool. So let's talk about a little bit of a recap from last week. Raphael gave a great lecture on plotting and a little bit of like how to read in data files into Python. So I guess how to plot lines. Can anybody remember or tell me like what the library is that we use to plot with? Starts with an M. Exactly, right? Matplotlib. It was originally developed in MATLAB, but then they ported it over to Python. That's why it's called like Matplotlib. It's like a library from MATLAB, but it's fine. It's for Python. We use an alias, like common nomenclature for like all of coding in like any field is to like use that alias as PLT. So whenever you go to like look up documentation, PLT dot whatever will typically give you the result you want on Google. And if we want to plot a line, does anybody remember like what the actual like line is to plot like just a standard line that we used last week? Well, it was PLT dot plot, right? And then if you wanted to do a scatter plot, then it was like PLT dot scatter, for example. And there's tons of arguments that you can add in there. And don't worry, it's a lot of you told me that was a little overwhelming. There's like way too many things going on in terms of arguments, like for your functions that we're using. Like the PLT.plot had like 20 different arguments in some cases. Like, how do I know what to use and what not to use? Your questions will be answered because we've made a resource for all of you that will be like very, very crucial for your understanding of plotting. That whenever you have a question, typically, as long as it's a fairly like basic level question that doesn't require a lot of complex thinking in Matplotlib, we have a resource. I call it the Ultimate Plotting Guide, and I'll show you how to access that on B courses in a little bit. And then like having multiple lines on the same plot, we just have multiple PLT.plot statements or PLT.scatter and plot. It doesn't matter, but multiple of them in the same figure is how you put lines on top of lines or data on top of lines. So I have a little small group question for everybody. We're going to take about 5 minutes to discuss with like the people around you, preferably like just your table. So my question to you is like, what would I see if I wrote this following code? Assuming that we already wrote like what x is, like a linspace, np.linspace for x, whatever it could be from like 0 to 10 or whatever you want it to be. We have a function f of x and a function g of x that we wrote earlier in the code. And if I wrote these two lines or like these 4 lines of code, what would be displayed to me? So just take like 5 minutes to discuss with the people around you and try and figure out what would you see on the screen. So go ahead and chat for about 5 minutes. Hmm. It's import Matplotlib dot and then add Decal. I don't have like but all right, like maybe 30 seconds left. questions in the chat. For the folks on Zoom, if you could unmute when you have a question, that would be great because I'm hiding the panel so I don't see it when I'm presenting. So just unmute yourself to interrupt me, please. Thank you. All right, I'm gonna hide this back. Cool. Just make sure it is being recorded. Yes, cool. All right. So can anybody tell me what they think they would see? I think you had your hand up first. Yeah, right. So we would have, like, we wouldn't see two lines on the same plot, right? Like we would see two different pictures. And the reason for that is because we have plt.show separating the first plt.plot statement and the second plt.plot statement. So essentially what's happening is you're creating like one image and then you're telling it, all right, I don't want to add anything more to it. I'm showing the plot now as like an image I want to display. And then we go to the next line of code and we create a whole new plot and then we display it again. So it's common practice whenever you're done with whatever plot that you've created to put a plt.show to end that plot so you don't accidentally add things on top of your plot. That was the whole point of what I wanted to get at here. So thank you everybody for discussing. Let's move on to lecture. So I have some really pretty plots. Something that somebody told me, I think it was Elon actually, is that astronomers have the best plots. I know not everybody in here is an astronomer, so you're going to learn from an astronomer and hopefully you make that not true anymore so that like you disperse it to physics or math or whatever field you may come from. We love making pretty plots. That is like one of my favorite things to do as a scientist. And I hope that that is like one of the biggest things you learn from this course is how to plot data and make it look nice. So Matplotlib, last week we talked about the very basics. How do I plot dots on a graph? How do I plot lines on a graph? That's great and all, but you can do a lot more. You can make it a lot more pretty. You can do lots of modifiers to make it look nice. You can display different types of data. How do you display multivariable functions that look like that one on the top right? How do you display in polar coordinates? Maybe you have some sort of crazy problem you're trying to do that I have no idea why, but you could display polar coordinates if you wanted. Maybe you want to show contour maps, like showing different heights and elevation in your function. Maybe that could be geography or like a map or like a model of like a planet's surface or something. Histograms, of course, everybody uses histograms in data science. Maybe you want to capture some sort of statistic. You want to see where the mean of your distribution is for test scores. Maybe it could be COVID data, whatever it is you may want. These are all things that you can do in Matplotlib. And also, how do I display multiple plots next to each other in like a really nice organized way? Do you have a question, Kate? Yeah. Well, we upload them typically Thursday after the second lecture because we like want the attendance forms to be filled out before Thursday. Does that make sense? So that we know that you're coming to lecture, you're watching the lecture, and then afterwards we check attendance that way. But perhaps we can change that around so that so that we mark attendance so that people. Yeah, it was on the first slides. We can go back to it at the end of a lecture. Yeah. Cool. All right. So the first topic I want to talk about with more advanced plotting in Python is subplots. So how do I make something that looks like this, right? So that I have multiple plots next to each other, maybe displaying slightly different information or different time steps. Don't really worry about the text, what's on these plots specifically, but just this kind of like structure of a plot is really what we're going to be trying to mimic. In order to do that, we have to learn a little bit of new syntax that can be really confusing for somebody that doesn't feel like they're really well versed in Python. And for example, this is just like, I think different seasons or something with some weather plot. But if we want to plot like these 4 different plots next to each other in a graph that like actually makes sense without using Photoshop, we can actually do that with subplots in Python. So we have to understand what's happening behind the scenes. So the structure of like any like Matplotlib, I guess any Matplotlib like plot that you make is like as follows. So we always draw like a figure, and inside that figure we put plots inside of it. So typically the standard default is you have a figure with one plot inside of it. So people tend to get confused and just, or not confused, but they're not technically correct when they say a figure or a plot and call them the same thing. They're technically not. So the way I like to imagine it is a figure is kind of like a canvas, right? And on that canvas, you can actually have multiple different images inside of it. Maybe you segment it up by like just straight lines on your painting, but it could just be like you have like an image of the sun or like something over on the top left, and you have something else on the top right. You have something else in the middle or the bottom, and you can like divide up your canvas into different subplots essentially, or like figures. We call them plots or subplots inside of a figure, but that's just nomenclature. So this is kind of what it looks like. There was supposed to be a box around this. I don't really have the tools up to to annotate this, but in the figure, just imagine it's like a really big box that plot 1 and plot 2 live inside of. And we can actually add more than one plot. We can add more than 2. We can add lots of them. You can make grids of plots if you wanted inside of one single figure. And you can reference each of these plots individually as like different objects inside of that figure. So there's 2 different approaches on how to like write Matplotlib code. What we've been showing you all of last week was called the state machine approach. It's basically like very limited in the sense of what you can do. You can't make like really cool figures like this. Like you can't do that with the state machine approach. If you tried, it'd be like really a pain in the butt. So it's meant for more like quick and dirty plotting. If you only have one figure, and it's great, you only need to do that, or not one figure, one plot inside of your figure, then that's great. Like really quick and dirty. If you just want to plot a line, by all means, this syntax is probably the faster, easier way to do it. Just a plt.figure, plt.plot, plt.show. Figure creates that whole figure box that the plots live inside of, and then plt.plot is just plotting the one plot inside of it. Anytime we add an extra plt.plot underneath it, it just plots it on the same line. It's adding to the same plot inside your figure. It's not, you're not specifying whether or not there's multiple plots inside of the figure that you want to reference. And then plt.show is always standard practice to end your figure that you're creating. So this allows us to do single plots quickly without worrying much about syntax, really quickly. Then there's the object-oriented approach. This is like what you want to do if you want to make like a publication level plot or something that you would want to put in like a presentation. This is when you want to really get into like the weeds of what you can do to customize your plots. The most customization can be done with the approach on the right. We call this the object-oriented approach. And what we're doing is creating like a custom plot object or an axis object. And what I mean by axis is like, we call this plot 2 or plot 1 like its own axis. So this would be like axis 1 and this would be like axis 2. And we can actually create these axis objects and modify them. We'll talk more about object-oriented programming later in the semester in a couple of weeks from now, so you can understand like what I mean by that, by like modifying an object. But you could just think of it like literally as an object that you would hold in your hand, like an apple, and you're adding modifications to it. Maybe you want to carve little things in it or whatever. It's the same thing. We're creating an axis object that we modify. So when I do ax.plot, it's literally modifying this axis object that I created in the beginning to be slightly different than it was before. So before you do this ax.plot line, it was actually just an empty axis, literally like what we have here. It would just be empty like this. But once you add ax.plot, it adds that line, that plot of like f of x versus x onto that axis. And now that's modified. You can also, like, it's the same idea where if you do like ax.title or set title, that would add a title to the top of your plot and so on. And the beauty about this is that we can create multiple axis objects, more than just one. And we can put them in different orientations, depending on how we write this first line of code, this plt.subplot. So right now I just have 1, 1, which just literally means I'm making a grid of 1 by 1 plots. But if I wanted to make it a 2 by 2, where I have the same structure I have here, like 1, 2, 3, 4, a 2 by 2, then I would just change these arguments to 2, 2. And it would let me create a cell, or not a cell, a figure that has 2 subdivisions on each side, aka making a 2 by 2 box. And then plt.show is at the end. So just to summarize the difference between these two, state machine is quick and dirty, getting it done really quickly, and like less syntax to worry about. But the object-oriented approach allows a lot more flexibility. It takes a little longer, or it's a little bit more complicated to understand, in my opinion. But once you have it down, it's a lot more robust in what you can do. There's a lot of like complicated little tricks that you can do to make these plots look a lot better. And you can add multiple plots in the same figure. Cool. So let's talk a little bit about the syntax a little bit more. So this is the object-oriented approach on how I would just make a simple plot like the one you see on the right. So let's start with X and Y. X is just a linspace from 1 to 10 with 100 little steps in between, evenly spaced. We talked about this last week with Raphael. Then Y is just the sign of that X. And we're just using the sign function from the NumPy library, just like we were using the linspace function from the NumPy library as well to create X. Now we're using the sign library to, we're using the NumPy library's sign function to modify the X, or to create a Y array from X. Once we do that, we have our X and Y data. So now all we need to do is just plot. So we're going to create an axis object and a figure. Plt.subplots returns two different things, a figure and an axis object. The figure is the giant box that you can put your subplots inside of. And then the axis object is just one of those subplots. Now, in this case, I'm only making one plot, or like one plot inside my figure. So it's the same thing as doing plt.plot or plt.figure with the state machine approach. But nonetheless, this is the kind of formalism you would use. So we do plt.subplots to create these different plots, except we're only doing one. Now we have an axis object. We call it ax.plot, or we modify it using ax.plot. And we're just literally plotting X and Y. So X is on, or this linspace from 1 to 10 is on the X axis, and then sign of X is on the Y axis. Similarly, a couple things change a little bit. So with the state machine approach, you might remember that it's plt.title, and then you put a string in there and it creates the title. In this case, it's slightly different. All that changes is instead of .title, it's .set title. Same thing with .set X label, .set Y label. You're literally just adding a set underscore before. It's some stupid syntax that I really don't understand why they changed it. It just makes it a little more confusing. But if something doesn't work right away or you get an error, just typically know that it's probably just a slightly different. You might need to put a set underscore before whatever you did. But that's it. That's really the difference. And then we just do a plt.show to kill the figure or end the figure off. Make sure that there's nothing after, like, being appended to it after we're done. So just to summarize, the what? Okay, we'll just do later. Hopefully that's not an issue. If I get dropped from the call, it's my fault. So again, just to summarize, we create an axis object with this line. Then we modify that axis object with like a .plot statement, .set titles, .set X label, .set Y label. Those are all modifying this object that we created in Python. And we'll talk more about like the nitty-gritties of how to create your own objects later. But just think of an object as like a list, right? A list is an object that you can like add things to. You can modify it. You can change things inside of your list, like with a .append or with a .extend, or maybe you can index it into it and change things into it. It's still an object in Python, and you can modify it. This is the same idea. It's just a plot figure or an axis object. Cool. Now let's get into more fun stuff. I call these 3D plots because you're plotting X, Y, like an XY grid, and then whatever the color is that you see, or the color map, is the 3D values that would be coming out into your face. This is a little different. We use a plt.imshow. Just notice this is state machine syntax, but you could also write it in the object-oriented approach, which you will be doing on your homework. So it's slightly different in the sense that we create, like with plt.imshow, we put in like a 2D matrix, and we're plotting their values basically. So this matrix, for example, is like a 2x2 array or a 2D array. You had some fun making those in your last homework assignment. If you remember the checkerboard problem, we'll have an example of you plotting that. But you just imagine like this kind of like X and Y grid where you kind of create like a mesh where you like divide it up just like how you would in your math class, like drawing on a plot. And then we're going to plot values in and out of it. Like this is very much like multivariable calculus, except we're not doing calculus. We're just plotting those functions that look really pretty. So here's an example. It's a little bit of a lot to discuss, so we'll go line by line with it. And then to kind of construct the whole thing at the end. So X and Y, we're just creating them from this np.meshgrid function. So meshgrid is just a function from the NumPy library, And all it does is it takes in like an X array and a Y array that are lin spaces. So X was like from -1 to 1 with 100 evenly spaced steps. And Y is from -2 to 2 with 100 evenly spaced steps. And we're just constructing an X like these 2D arrays called X and Y. It's just like getting it to be the same like shape. You're basically making X and Y like they're like a combination that captures all of the grid essence of this figure right here. You're basically making just a bunch of like different little cell values that you can fill or not fill, but use to create like an f of x comma y function. So just think of x and y as like your x and y values that you would put into a continuous function like f of x comma y. And in this case, I'm just plotting like a function where we say x plus y is f of x comma y. If you haven't seen multivariable calculus yet, or just like any multivariable functions, don't worry, you will see them very soon in Math 53. I think everybody has to take that that's in this room. So don't worry if you haven't seen it yet, but they look really pretty, and you're actually like, whatever you're looking at, like the yellow or the red or dark red is like kind of, you can imagine it as like heights coming in and out of the page. And this is like really a three-dimensional type of function you're looking at. Another way to look at it is this. This is like basically what you're looking at from 3D, from outside of the page on the top right. And we're looking at like, and we're plotting it like this, where you're looking at it from like a top-down view. Cool. And I'm just doing a state machine approach right here. Super simple. Plt.figure creates the whole figure that we're going to put a plot inside of. We're doing quick and dirty because we only want just one plot. We don't need to be super fancy with anything. Plt.imShow is the function we use to plot this type of, like, make this kind of plot. And then we just literally put in f, where f is like a 2D array with different values. So a 2D array meaning it has the structure of a matrix, but each value is like a different value corresponding to f comma x, or f of x comma y. And we created those values by saying f is equal to x plus y. NumPy works really nicely. It's kind of designed to be like this, where it's kind of intuitive when you want to write functions like this. Technically, if you wanted to be like super rigorous, you could define a function f of x comma y and add them inside. But NumPy arrays are super easy and robust, so we just add them like this. But you can definitely make your own function that takes in x and y or z variables or whatever, and spit out or return a value for each index. Then plt.imShow, we just do f. And then I have a couple interesting arguments here. I just want to highlight two different arguments that you will commonly use within the imShow function. CMap is short for color map. So what values correspond to what color? There are so many, and I will show you like what they can look like, how they can change what you're looking at. I have a couple favorites that I'll show you later. And then origin just change. You can change where the origin is in your plot. Maybe you want the origin to be the bottom left. Maybe you want to be the top left, the top right, the bottom right, depending on if you're doing like things with computer graphics or like normal plotting or whatever it may be. You can customize it to your liking. Those are two common little things. And then to add a color bar that we have on this right, we do a plt.colorbar. These are all going to be encapsulated in a plotting guide. So don't worry if you don't, like, this is a lot of information. I totally understand you to just remember it off the cuff after this, but you will have a guide that you'll be able to look at later and reference for things like this if you have any questions. And then of course we do a plt.show at the end. And I just want to stress that like everything we've learned before can still apply. So if you want to add a title, it's plt.title and then the name of your title. Same thing with an X label, a Y label, and so on. You have all the different like modifications you want to add to your disposal. Is there any questions about this so far? Cool. All right. So, oh, sorry. What's up? Yeah. So it is technically discrete in the sense that it's not like fully continuous. But we have 100 little incremental steps from zero or from the bottom left to the far right. So 100 little steps. So 100 by 100 is fairly smooth to the human eye. But if you made this like 12 and 12 instead of like 100 evenly spaced steps, then it would really be like a full like grid. And you can see that in this next slide that I'm about to show. Oh, sorry, you have a question? So what that function does is it takes like a 1D array for X and a 1D array for Y, and it turns them into a 2D array so that you can use it in to make like a 2D array like Z value from them. So you want them all to be the same shape when you add them together. So all Meshgrid does is basically takes like a string of X values or a list of X values and a list of Y values, and it creates the whole XY grid from them. Does that make sense? Cool. Yeah. So we give it like all these X values and we give it all these Y values, and Meshgrid creates the whole XY grid from them. Cool. All right, let's move on to the next bit. So you can plot 3D data. We'll like write this down like in a second, like live. But let's say you have like a CSV file, a comma separated value file, aka like a text file with values inside of them. And it looks like this when you look at it. It's got ones and zeros, ones and zeros. You may remember that you made this in your homework if you hopefully did the first couple questions. So like imagine you put that into like a text file or a CSV file. You could read it in with np.load text that we talked about with Raphael's lecture last week. You could store it as a variable, and then you can plot it. You just plot like we have this array of values, this matrix, and we can plot it like so, just using a plt.mshow. The plt.mshow of checkerboard data, where we loaded checkerboard data as this text file and stored it as a NumPy 2D array. And then you can plt.show, and it looks like that. It looks pretty cool. Where should I go next? I just want to give you a couple like glimpses of what you can make with these kind of plots that look really pretty, in my opinion. So on the left, I believe Isla made this plot, or Emily, I can't remember which one of you did it, but this is the Mandelbrot set, right? Or delete set. So this is like fractal, referring like a fractal where you like infinitely divide it in on itself. It's like a recursive. It's like literally an image that's recursive. It's temple. So if you kept zooming in, it would repeat the same image. So that's really cool. You can make like one of those. This is like an image of silicon with STM. So if you take 137B with Michael Comey, he like literally does this. This is like from his research. I don't know if it's like a data set that he made, but it is available. It's like literally a silicon atom, or like the surface of the silicon atom, or molecule with lots of atoms next to each other. And then this is just like some function that I came up with that looks cool with a contour plot on it. So these are just like some examples that you can make with IM show plots. Cool. So now I want to show you the ultimate plotting guide. We have it at your disposal. I uploaded it to B courses, so I guess the first place to check would be here. If you go to Files, and we go to Resources, then you'll see this Ultimate Plotting Guide notebook. And if you click on it, you'll see some pretty cool stuff. I happen to have it like on my files somewhere in here. Just give me a sec. So if we look at it, this is what it'll look like when you open it up. Hopefully it's not blank. It shouldn't. Anytime now. Yep. It shouldn't be blank. Yeah. Okay, there we go. Just took a hot minute. Okay, so it's got all the basics essentially, and then it's got progressively more and more complicated things in it. So if you walk through it, I encourage you to literally go like cell by cell and just walk through the whole thing. And I think it'll really help you get a sense of how to plot, but I'll let you do this on your own time. We won't do it in lecture, but I just want to give you a quick little glimpse. You start with like a basic plot, and then you start like doing like plotting functions, and then you can plot multiple things on top of each other. You can make it bigger. You can put labels on your plots. You can beautify your plots. You can do error bars. You can add data on top of those error bars. You can do like log scales, for example, histograms. Here's some examples of subplots that I have for you to practice with. Here's like more and more of them. Here's like some cool like spectra data. If you're taking 7A or astro classes, you might know what a spectrum is. If not, that's totally okay. And then like we have some examples of how to make your plots look pretty so that it's like in a nice font or whatever. And then we have like different kind of types of plots. We could plot images in Python. You can do like really cool like polka dots if you ever wanted to, flowers, I don't know, whatever suits your fancy. We got tons of stuff in here for you to look at. So this will be available for you on your own time. I encourage you to look through it. But for now, let's go through a nice little example of like how to do some code. So I sent out an announcement last night, like at 1 in the morning or something. If you didn't see it, that's totally fine. But if you have internet, you should download from B Courses. I uploaded a little file under lecture demo, or a folder under lecture demos, advanced plotting. Try, if you can, download this CSV file as well as the non-solutions. I mean, you can download the solutions if you want, but I think it's a lot cooler if you don't. So download like the regular, the non-solutions and the Astro image CSV, and then put them in the same folder, and you should be able to follow along. But if you want to just watch, that's totally okay. So before we start coding, can everybody see that? Yeah, I think that's a reasonable size. Let me just check to make sure. Oh, there's a thing in the chat. Yeah, Ellie, I will send the attendance, or if one of the instructors is in the Zoom call, or could you send the attendance in the chat, please? Cool, and then we'll go back to hiding. Okay, so we always start any notebook with a preamble. This is like, all I'm doing is bringing in NumPy and Matplotlib. Typically, you'll always just copy these over to any notebook. They'll just be like in the first line. They should be. Import matplotlib.pyplot as PLT. You're gonna get really used to writing that, as well as import numpy as numpy, or numpy as np. And then this like matplotlib inline is just like a modifier. You don't really have to have it, but I like to keep it there anyway. So I just want to do, I might give some people the answer to the very first, or like the first question of homework 3, but that's okay. We're gonna plot the checkerboard example. We're just gonna do that really quickly. So first we got to create it. So I'm just gonna do this kind of quickly. Hopefully you know how to do this from your homework, but if not, I'll kind of explain it. So we're gonna first start with like a whole 2D array. We're gonna use mp.1s to make a 2D array of like an 8x8 array. And we're gonna set those, set it to integer type. Like we want these to be like ones, like literally just ones. And then what we're gonna do is we're gonna just use some really clever indexing, where we start at not the very, like the 0th element, but we start at the first element and skip every 2 values for the rows. And then we do the opposite, or not the opposite. We skip every 2 rows from the 0th value going through the columns, and we set those equal to 0. And then we just do it again, like reversed. So we just switch the rows and columns indexing on the next line, and we set those to equal to 0. And then now if we print checkerboard, if I could type, there we go. If we print that, of course we get an error. Oh, I didn't run the preamble. My bad, it's fine. Oh, we got all, it was yelling at me, stop it. Better now. And then we get like these 1s and 0s that look really cool. So that's a checkerboard, but we want to plot it. Let's make it look pretty. So all we have to do, we'll start with creating a figure. PLT.figure. We'll set the fig size. This is just one argument that's totally going to be in the ultimate plotting guide. So don't worry if you don't know what this is. You'll be able to see it, how it works in the guide. So we're going to start with creating our figure that we're going to put a plot in. And then we do an IM show statement. And we literally, all we have to do is set checkerboard, or just put checkerboard. And if we just run, or we do a plt.show right after that, it should plot something that looks like this. Ew, that looks really gross. I don't like those colors. So let's change the color map. We get like, there's tons of different color maps to change. CMap was one of the arguments that we had on the thing. For example, just one of them that I can think of off the top of my head is one called hot, and it changes it to like black and white, for example. That's hot, right? But yeah, so there's a checkerboard. It looks kind of cool. We can also change the origin. You see that like the origin right now is not actually the bottom left. It's like the top left for some reason. So we can change origin equal to lower, for example, and that'll just slap that boy right in the bottom left like that. So now it's 0, 0 is in the bottom left. Cool. Is there any questions about that so far? The code? Yeah. Yeah, I think it would be like lower space right, but you can just Google this. Nope. Is it like, I don't know, lower right? Maybe it just like right? I don't know. Yep. I don't know. You just Google origin argument matplotlib and it'll like totally give you all the options. But off the top of my head, I don't remember what the options are. So I'm just gonna like pretend I didn't hear that question. We can talk about it more after lecture, or you could Google it. All right, let's move on to the next thing. So plotting continuous 3D functions. We kind of talked about this in lecture, but let's just do a nice little example. So let's create a mesh grid. So I'm just gonna say x comma y is equal to np.meshgrid. And we're just going to put 2 lin spaces, one for the x and one for the y. And we're just going to set them from 10 to 10 with like 100, or we'll do 1,000 spaces because we want a really high resolution. np.lin space from -10 to 10. This is for the y. So that creates our x and y values that we can fill in our grid. And then we just use some really nice NumPy syntax to not even have to write a function, but we could just say f is equal to the np.sine of x times y. And then we can add np.cosine of x to that. And that'll create a function where f of x comma y is literally sine of xy plus cosine x. Okay? And now we just plot it. So let's do plt.figure. It's always good habit to like initialize your figure. It lets people know that, oh, I'm about to start a plotting figure. And I'm just gonna set my dimensions to be like 8,6, meaning like 8 whatever units width and 6 whatever units height. I don't know what the actual units are, but it just makes it like a nice ratio or aspect ratio. And then if we do plt.im show of f, and then we could do like, I don't know, we could do like cmap is equal to like inferno. That's a cool one. I like that one. And then we can add a color bar. And we'll do plt.show to end the figure. And it should look really, yep. Huh? Oh, fig size is equal. There we go. And it looks like that. Ooh, pretty. Yeah, I think that was a pretty cool one. We can play around with it too. We could also, I don't know, we can make this a sign, see what happens. It doesn't look that different, but maybe I could do like of y. Ooh, and it like looks a little different. But I encourage you to play around with whatever functions that you may come across in your Math 53 class. Maybe like just like Google them. You'll see lots of cool ones that I handpicked that will be kind of annoying to type out, but they look really pretty on your homework. So stay tuned. Is there any questions about plotting like continuous functions? Good. Where are we at on time? All right. I have like one last example that I really want to show you because it's super cool. So let's say you have like a really cool data file called image data and you want to load it in. So I already supplied this to you if you download it from the B courses. It's called like astroimage.csv. It's literally just like a bunch of numbers for like pixels of an image, but we can actually plot that. So I'm going to load it in as image data. And then all I'm going to do is like create a figure again, where we say fig size is equal to 12,10, which is just like a really big aspect ratio. And then I want to do plt.im show. I'm going to plot image data. And then I'm going to do a color map. I'm going to set that equal to hot again, because that's my favorite. And I'm going to set like the Z values to be like a minimum of something and a maximum of something. So V min is going to be equal to like 50. Or actually, no, we won't do that first. We'll come back to that. We'll do that in a second. And then we'll do plt.xlim. We're gonna like do a little stuff. I can explain this in a second. It's not super important. It's just like setting the bounds of the x axis. But let's see what this looks like. It's not gonna look very cool, I don't think. It's gonna take a second though. Why is it taking so long? So we see like this, and it doesn't look really cool. You can barely tell what it is. But so let's change the bounds to be some like to make it more recognizable. AKA, let's like limit the range of pixel values that we want to see. And then now, if I do this, it'll take a second because it's a big file, but it looks like that. Yeah. So that's like an actual image. Like you can plot this. Like this is like taken with the Hubble Space Telescope, like that orbits around the Earth, like a couple miles above the surface. So yeah, like you can plot that. You have access to that now. Yeah. So you just import the image data. I converted it to a CSV file for you. And then you just plot it with IMShow. And I like hot, but we can see what it looks like if I do different colors. Let's do, we could do, well, Inferno looks the same. Why don't we do like, let's do this one. This is a color map that I think looks really cool. Looks like that. That's kind of cool. Like, yeah, it looks like inverted. We can also do, we can reverse the color map by adding like a little note thing. And give it its hot, sweet time. Oh my God, this takes forever. There we go. And it looks like that. But I encourage you to play around with the different color maps. You could just Google like Matplotlib color maps. And if you go to this web page, you can see like all the different ones that you have at your disposal. These are the names on the left. Like literally just play with them. Like, oh my God, they look so cool. So you can really make it look like really cool. But anyway, that's lecture time. It's 3:01. I don't want to take any more of your time. Thank you for coming. Make sure you look at the plotting guide. It will help you so much with your homework. I cannot stress that enough. Look at the plotting guide. All the answers to the homework are basically in the plotting guide. So go to look at the plotting guide. Have a really great rest of your day, everybody. I'll stick around if anybody has questions, but yeah. Thank you. Welcome. Hi, Roger.
For the checkerboard, so basically, takes in the 2D array.
Mm-hmm. It's just setting the origin up, or like this is putting the origin here. Basically, like this is like 0 or like 0, 0, 0, 1, 0, 2, or whatever. Maybe it's like
in each index, the number corresponds to a specific color.
Yeah. Well, like so these are ones and zeros. Yeah. So if you do a plt.color bar underneath this, like if you like just add a plt.color bar line, it'll say that the blacks are like ones and the whites are zeros, or the other way around. I can't remember.
And the color is kind of default setup at the IMShow function.
Yeah. Well, this is just this color map that we chose. You can, if you change the color map, you could see like what it will be. It could be different things.
Yeah, I mean, if you just remove this, then there will be a default value for this color map.
Yeah, exactly. It's just like whatever.
And for this one, for example, like if you just, it will automatically appears a color bar that represents the Z value, which is like the multivariable takes an X and Y.
Yeah, the Z value. Yeah. So I encourage you to change it. Like get rid of it, look at different combinations. Yeah. Like that's the best way to explore it.
It can like show the a 3D graph in 2D dimensions and use the colors to stand for different Z values. Yeah, cool.
Yeah.
Tell me, what is the
Yeah, so it's just like, so this is what you're plotting is like a 2D array of pixel values, and each value, like
this is at 0, 0, for example, it literally is like 0.1, and here it's like 0.1, 0.1, 0.1, and then here it's like, or not 0.1. Let's say this is like, I don't know, 100, and then over here it's like 400, and over here it's like 200. So every like index of your matrix has a different value, and vmin and vmax is just saying, okay, I want my color bar to start at this vmin and start at this vmax, or end at this vmax. So like if you change it around, it'll basically truncate. It'll just color any values below it white, and it'll color any values above 400 purple, like dark. It won't add any more colors.
All right, so, but then why do we have completely black one in which or like put in all the more
Well,
so
so
the reason is that
So I encourage you to get rid of the line and see like what the color bar values are. So right now we're at 400 to negative 400.
all right.
It'll take a second, but
All right.
so we'll look at all the color is white. It's like basically around 0. There's nothing here at 3,500 except for this little pixel, right? So there's no point in like, we just truncated it down here.
So what's the value corresponding to?
The number of
the
like the number of photons that came into the like camera, like literally the number of like,
Can I see it as brightness? But and then
yeah, or okay, the number of photons is a bit of a approximation. It's more like the flux coming in, like the light from the object.
that argument's name starts with V. The V.
No. Vmin, Vmax is like vertical min, vertical max, like out of the block. Yeah. It's just whatever the argument. Like if you Google it, it's just like, it's literally like the Z values. It's the same thing. Like you could do the same thing here. You could say Vmin, Vmax, like Vmin is 0, Vmax is 1 or 2 or whatever, and it'll change the like where you truncate the color map.
But,
Cool.
What are these things?
Yeah. So
how can I interpret?
right. So okay. So with a list, right? You can always index a list with like there's we call it like splicing or indexing, where we have like this syntax where this is like a starting index, this is a stop index, and this is a skipping index. So if I set this equal to 1, it's going every value in a list. So let's say that this list was like 1, 2, 3, 4. If I put a 1 here, it literally needs to go every object. But if I did 2, it would be every other.
All right.
And then this is the start index. So if this is 0, we start here. If it's a 1, we start here. And then similarly, this is the ending index. Where do we stop? Here or here, like -2 or 3 or 4 or whatever. So what this is saying is we don't care about starting and stopping on this bit right here. We're just starting at the very first thing and ending at the very last thing, but we're going every other 2. And then this is starting 1 shifted over. So you have this, it's like saying we're like, this is like, these are all 1s, right? Right. So it like, this is saying we're gonna go every other row starting here like this, and then this one is like the next bit is saying we're gonna go every column starting at the first index. So like starting here and going.
So the column separates the row and the column.
Yes, yeah. So for a 2D array, it's another index, right? Because a list is a 1D array. This is a 1D, so you only have one thing you can go over. But a 2D array, you actually have a whole nother thing.
Yeah, dimension.
Yeah, right. So if I have a matrix A, you can refer to it by the ith row or ith row in jth column, and that gives you like a specific value. So you have 2 indices, whereas if you just have a vector, you have 1 indice. And if you have like a box or a tensor, you have like I, J, K, 3 indices. And that translates to one. Right. This translates to 1 comma, and then. Does that make sense?
So, but I thought the comma it's split to 2. So then this thing represents something.
Yeah, the 2 is like the skipping. So
the 2 is just a 2. The comma is separate row and column. This is-
Yeah.
First,
Rows, columns, and this is treated just like how you treat a list.
Right.
And so is this.
All right. Gotcha.
All right. So what's your question?
They have to like.
Oh, yeah, yes. Here. It's right here. If you just like here, it's or can you do a QR code instead?
Yeah.
Okay, that'll probably be easier. Cool. Stop recording. Yeah. Anyway.
I'll be able to catch